Hello, and welcome to Ants Are Everywhere. Today we're taking a look at the source code for Lichess, which is a popular free and ad-free chess server. And it has a lot of cool features. Here's the site. You can do things like you can play games, you can play different kinds of tournaments, you can play variations. And it has things like learning. So you can do like chess basics. You can, I guess, study the coordinates. And it's got a nice puzzle system. I think the puzzles are a lot of fun, and you go through the puzzles. And I'm not going to do this live, but that's what some of this is about. And this Lichess project is our first request that I'm doing in the new regime of requests. I'll bring this spreadsheet over here real quick. So we're doing Lichess. And as a reminder, the way the requests work is there's some donation amount associated with each of the repos. In this case, 1 cent was enough to choose Lichess. So if you want to support the channel, Patreon's a good way. I think there's YouTube things that you can send. But if you want to make a request, or if you want to vote on a request, that's the mechanism for doing it. And if you want this link to this spreadsheet, you can hop over on the Discord, and it's there. All right, and so on the spreadsheet, the user who requested it, so, there's a column here about why this repo is cool, and the user who requested it put a couple of things. First, they mentioned Fishnet, which is a game position analysis thing, and another is that this the opening explorer for exploring chess openings, and the puzzle creator. I think here puzzle creator is, if I'm understanding correctly, there's not a way to directly create puzzles that other people do. I think instead what you do is you do a study, and then you somehow promote the study to a puzzle. So I'm going to kind of take it as if that's the mandate. And if you are watching and there's anything in particular you want to see, then let me know. So Lichess is nice enough to give us a diagram. In fact, all of their documentation is really good. A lot of it's in Scala. Lila, I think, is the repo that will be most interesting to look at. I don't know Scala, but and so I'll probably be a little bit lost during the stream. But they have this architecture diagram, which I am going to look at. In fact, I had already opened it. And so there's a lot going on here. So the backend, I don't know if Manta is the code name, but this thing they call Manta has the Lila Scala server. There's an Nginx reverse proxy, and there's one here and one here and one here, one here. No, there's not one there. But they're basically using Nginx as a reverse proxy. If you were doing this on Kubernetes, that would kind of be taken care of invisibly for you. But then there's Lila. It's talking to Redis as a sort of pub subsystem. And there's a bunch of databases. So this is the list of main and secondary databases. There's a study database. Rubik, I guess, is the puzzle database, presumably named after Rubik's Cube. I don't know what YOLO database is. And then there's some anti-cheat stuff, which are named. So Irwin, I guess, is probably the name of the repo or the product, and then Burke, Butch, and Uluru are possibly the names of like deployments. And so that's kind of an overview of what's going on the back end. We're not going to see all of the repos for these. I think one box relatively is probably around one repo. But since I was asked about the Fishnet and the puzzle creator, I want to at least say a few things about that. Fishnet looks to me like it's essentially doing volunteer computing, in the sense that you set up your computer, they'll send you a game to analyze. You analyze it using Stockfish, which is a really cool chess engine, but is not it's not something that I believe Lichess wrote. There may be some overlap in the developers. I'm not sure. but that's what's going on. And so here's a diagram of how Fishnet works. So you run Fishnet on your computer. There's a Stockfish benchmark, which is going to, I guess, auto-config itself. And then you ask the Lichess server for work. It selects the most urgent game that needs analysis, sends it to you, you analyze the result and send it back. I don't know if there's anything here that's like, I don't know how they handle people who, maliciously try to analyze chess games. I don't know if there's any protection, or if they, you might imagine they send it out to n different people, and if they all agree, they assume that the analysis is correct or something along those lines. So that's an interesting distributed volunteer computing project, but I don't think that it's entirely chess related, and I think that Stockfish really deserves its own video. So I'm not going to really look at the Fishnet too much. And for puzzles and studies, my impression is that the way that they're doing things is they essentially have strings that describe the chess games and the chess moves, and the way that the features work, like maybe here, this is the play out of a game. So e4 means, I guess, pawn moves to e4, the black pawn moves to e6, and you just write this out as a string. And then once you have that string, you can search it. And if you go to the openings, I'm not exactly sure where Openings Explorer is, but you can search for openings. So is there a King's Gambit? So you can just do a text search. And then as you're exploring openings or doing analysis, you move the pieces around. Of course, white starts first, and then I assume that the way this is happening is it knows from the UI that this is the move d4, and it's going to essentially do a prefix search for chess games that match d4 followed by e5, and it will look it up on Wikibook. There's this chess openings wiki book here, and this is the and I think they're essentially just doing a d4 e5 search and pulling up something like this. In fact, you can see d4, whatever. I don't know chess notation that well. In fact, I would say that I don't know it at all. I don't know what this /1 followed by e5 is, but it's some move. Okay, so that's my sense of how it works. And so for that reason, I want to focus on a couple of things. I want to focus on how they're representing games, probably as text, possibly as something fancier. And then I want to look at a little bit about the UI, because some of the magic is in how they've presented the interaction with all of the chess features in a nice way. And we may look at some of the backend stuff, and we'll just see where we are from there. All right, so let's jump in. And actually, before we entirely jump in, let's double check the repos. So there's the API repo. Scala Chess is the repo that has the chess rules. It's written in Scala. I assume that this is their repo. This may be a library that they're using. There's a WebSocket server. Yeah, that's what I meant to mention. And what? There's a PGN server, I guess serving images of what kind? I don't know. Maybe just any images on the site. I don't know if they're necessarily chess specific. There's a mobile client. There's some Docker stuff. And if you go on YouTube, which I encourage you to do, they have a really good developer outreach program, in my opinion. And I would encourage people who want to work on Lichess development to check it out. The latest thing they're doing is they're using Gitpod to allow the user access to a web-based reproducible environment. It's similar to some of the tools that have existed internally at places like Google for a while. But the idea is that the whole environment is just taken care of for you. You just hop in, make some edits, and hop out. There's probably a little bit more than that. You probably need an account on Gitpod. I don't know if you have to pay for anything. And I think in the video, they said it like takes 10 minutes to set up. So it's not necessarily instant. But that takes a lot of the hassle out of having to set up Scala and the Scala build server and the language server and all of that stuff on your local machine. Previously, they were using, I think, Vagrant to try to do all of that. But I think like moving to this kind of cloud-based approach is really good. So it seems like a nice project to work on if you know Scala or if you know chess. So I encourage people who are interested to take a look at their GitHub issues. And they've marked some as good for beginners. I don't know how much they're keeping up with that. But that's at least the ideal. And so there will be things that you can look at. And if you want to contribute, those would be probably the ideal place to start. And then here's Fishnet, which we already looked at. And there's some Flutter stuff. We've got some Dart stuff. So I'm not sure exactly what that is, possibly for the apps, the mobile apps. Dart, Chess, Lila engine. Okay. All right. So I'm pretty sure we should jump into Lila. I think there's also a WebAssembly stuff. And I'm not really sure. So Lila Stockfish Web. And yeah, so I think they're running Stockfish via WebAssembly. And I'm not sure why. I guess that means maybe it runs on your browser. But I don't know. All right. And so WebSockets is how would you create a game where two people are playing chess? I imagine it might be a lot like correspondence chess, which I think is a thing. Let's hope it's a thing. Correspondence chess. Played various forms of long-distance correspondence. It is usually through a correspondence chess server, the public internet. Well, now it is. Is there a history? I'm pretty sure that back in the day, there are ways to you just send the move you're going to do. You both have chessboard set up, and you just like mail each other, or you send a carrier pigeon. So, for example, a correspondence chess game was thought to be played in 1119 by King Henry I of England and King Louis VI of France. Okay. So I don't know exactly how it's done. I think I've seen it in movies where people, send messages or letters or whatever. But I think that's basically what's going on the WebSocket. You probably have to send additional data other than the moves. First of all, you need to know who's white and who's black. You might want to send clock synchronization information in a lot of chess variants, especially competition, like at the organized competition level. There are chess clocks, and you want to make sure that those are synchronized and those sorts of things. But relatively speaking, as a multiplayer game over the internet, there's a lot less information to send than something like a Doom or whatever. Okay, so that's enough yakety yakking. Let's jump in. And let's verify that this is still live. Because YouTube just told me I was live for 3 minutes. Okay, there we go. All right. The first thing I want to know is how are things represented? So we have app, bin, conf, modules, project. I'm guessing project is probably like build and config related. Public, I'm not sure. Translation is obviously translations. I guess we'll open public just for fun. And then we'll open UI. And there's a lila.sh, which is going to be a bash config. I mean, a bash script of some sort. I don't know what it does. Maybe this is build. It starts a dev console to compile and run Lichess. So you call .lila, and then you have an SBT thing. I think SBT is a build tool. A simple build tool. Okay. Far out. In app, we have controllers, HTTP. So this is kind of like the bridge between the UI and like the backend logic that understands what chess is about. So there's going to be some routing from the HTTP requests to whatever whatever part of the Scala library is handling that HTTP request. We have mashup, which I don't know what that is, and views. And then m.scala, lila.scala, Lila components, UI, env, and package. I'm not sure that what env is. Although, again, just to emphasize how impressed I am with Lichess.org as a place for developers, they have a really nice write-up here of what their stack is. So we've got features. It features a search engine computer analysis distributed with Fishnet, tournaments, simuls, probably simulations, forums, teams, tactic trainer, a mobile app, a shared analysis board, and the UI is available in more than 140 languages. And it's a community translation effort. How do they make sure that that the translations are not just trolling? And hopefully they have some system to like pass it into Google Translate and just verify that it's not just naughty words. And then it's written in Scala 3. It relies on the Play framework, which I'm not sure what that is. Scala tags is used for templating, so that's some template engine. The pure chess logic is in the Scala chess module, which I think we should look at. There's Akka streams, which are I think just asynchronous streams optimized for Scala. Scala is a mostly functional language, and so it's a nice like functional, I assume, streams environment. And then there's like a server for the WebSockets that communicates with Redis. And Lichess talks to Stockfish, deployed in an AI cluster. And AI here, I think, links to Fishnet, of donated servers. And it uses MongoDB to store more than 5.7 billion games, which are indexed by Elasticsearch. So MongoDB is just a like NoSQL, I think essentially key value store, probably eventually consistent, if I remember correctly. And the web client is written in TypeScript. I don't know what SnapDOM is, but Sass is a CSS thing. I think SnapDOM is probably like a DOM parser. I'm not positive why they need that, but you can look at that. And then a free PGN database. Maybe PGN is notation. I was thinking in the architectural diagram that it was PNG. PGN, I think, is something game notation. Maybe? That's my guess. Algebraic notation, chess. Algebraic notation is the standard method for recording and describing the moves in a game of chess. It is based on a system of coordinates to uniquely identify each square on the board. It is now almost universally used by books, magazines, newspapers, and software, and is the only form of notation recognized by the FIDE. Okay, so I have some like older chess book from I think the 30s, and like the edition I have is like new edition, now using algebraic chess notation. I don't know what they were doing before, but you could, I guess, imagine different sorts of notations. And that I don't know, like. If a lot of openings begin with like E4, right? Or E5. And I guess if there's no piece indicator, maybe that means pawn. Is that just... Each piece other than pawn is identified with an uppercase letter. English-speaking players use the letters K for queen, K for K for king, Q for queen, R for rook, B for bishop, and N for knight. Because K has been taken for king, and so on. Cool. So this is just really nice because I don't know any of these frameworks, but I now know how to look up the relevant things in order to work on this piece of code. And there's enough here for people to sort of jump in on the part of the stack that they're most familiar with. So Play is a high velocity web framework for Java and Scala. Okay, so it's built on Peko and Akka. I guess Peko is Play 3 and Akka is Play 2, although they're still using Akka internally for other non-Play stuff, I guess. Okay. And then Akka is a framework for distributed applications. All right. So this is Lila WebSocket. I think we're just going to ignore this, although maybe I'll bookmark it in case I want to come back to it. And then Snap DOM is not one of their projects, but it's something they're using. It's a virtual DOM library. I guess maybe just to explicitly model the virtual DOM the way that something like React does on the front end and to do fast thingies. And then TypeScript is just TypeScript. I was hoping that would link to their TypeScript repo. And then they have this open database of chess games. I assume that they're like scrubbed of username and personal identifying information, but you can download the PGN, which I guess means they pay for it, and then you can torrent, and I assume that they're seeding all of these torrents, so they're also paying for that. And then there's just variants like anti-chess. I don't know what anti-chess is, and also puzzles and evaluations. Yeah, let's. All right, let's look a little bit at Scala Chess and a little bit at the Lila repo, and try to figure out where we want to be. I'm going to kind of open up some of these Lila things just so I can see what sorts of things are in the are in each of these folders. So in controllers, we have things like events, exports. I'm guessing maybe to export games, feed, presumably something like an RSS feed of information, importer, internationalization, GitHub, game mod, game.scala. We'll look at game.scala. Lobby, I think, is just where you start out when you are logged into Lichess. Do I still have the lobby open? Stop it. I may not. I may have closed it, but we saw before. Maybe if I'm... Yeah. We'll pull that into its own thing. Okay. And we have a message racer. I don't know what racer is. Team is presumably some teams. Tutor. Looks like a tutor. User. Video. I'm guessing video is maybe support for watching tournaments and stuff. Relation. I don't know what relation is. Practice. We'll look at some of these. Opening.scala, notify.scala, main.scala. Main might be important. I also kind of might as well look at lobby. Why not? So this is Lila.app. And then here's the Lila root directory. Oh, that's app. So what else do we have? We have bin, project, modules. Modules might have important stuff, public and UI. So modules has, I don't know what activity is. Analyze is presumably going to be chess analysis, probably via Stockfish. API source is probably the implementation of the source handlers. Appeal, maybe that's like a ban appeal. Some bot stuff. Challenge, chat. There's like chat support when you're playing with people. Coach, CMS, maybe content management system. Common. Coordinate. Core. And then database, evaluation, event, etc. Game/source, gathering, lobby/source, opening/source, play, ban, plan, practice, puzzle/source, and so on. Some socket stuff, simulation stuff, shut up stuff, UI, source, main, and web. We're not going to get to all of this, but we should at least see some of it. And then did we see what was in public? I think public is here. Public has cursors, flare, font, images, JavaScript, logo. Oops. I'm not sure what oops is. Piece.css. That's maybe the vector graphic of a piece, or maybe it's just the styling for the graphic. Sound, vendor. Some JavaScripts with his S. Okay. So, and then piece we have, these I guess are probably different, like chess themes, different chessboards. So BB, I'm guessing is black bishop, black king. We'll see what those look like. So here's the fantasy. I guess it's trying to be, look like a Celtic priest or something. Here's the king. And so on. So these are like vector graphics. And then I assume that piece CSS is some sort of styling. Anarchandy, cardinal.css, chestnut, disguised, fantasy. And this is like telling you where the I guess, maybe SVG file is. I don't know what this long string is. Maybe it's an encoding of the file somehow. And so on. Okay. So that's piece information. Let's take a look at something else. So here's web. I don't think that's what I want though. Maybe main. We have nonce. I don't know what that's for. We have a router, which is presumably just going to be like routing information. It's really just imports. Lila router is maybe where the action's at. And this doesn't really look like a router to me. But we've got some stuff. I don't really know what this is. Something about users and strings. So I think this is not where I want to be. Okay. That leaves us with module web, puzzle. Let's look at puzzles. And they have tests. Tests are good. Let's see what tests they have. A JSON view test. So this may be more about the UI of puzzles. And we have BSON, which I think is like binary JSON. Binary JSON. Okay. We have daily puzzle, which should be the part of the UI that like tells you what the daily puzzle is. There is a daily puzzle, and this is telling you about it. See if we can find it on the web UI. Puzzle of the day is here. So you click on it and you go to /training/daily. Where was I? Here. All right, let's look at that. So this is Scala. I don't know any Scala. We've got some, we're using Bison for fields. And this is setting pipe to some list. I'm not sure what doc is here, but we're gonna, seems like we're maybe doing some matching here, and depending on the, I don't know if, I'm not sure, but we have plays, day, issue exists. So day exists false, issue exists false, themes, NIN, forbidden themes map key. I don't know what that means. I don't know what unwind field means. Replace root field puzzle. And then we're going to add fields, day score, multiplay, plays, and vote. And We're going to sort descending by day score. This is for find new. So this is, I guess, some finding a new puzzle. Find current. Okay, so I guess maybe this is a query that they are doing on the back end. And what was it, sorting by day score? I'm not sure what day score means, but possibly something like find puzzles that haven't been shown in a while. I'm not sure. Find new biased. Takes some int for a number of tries. FU, I think, is their abbreviation for future. It returns a future of optional, I guess, puzzle. And it has some, whether it needs to try again. It's going to import the puzzle theme, or rather import the puzzle theme library. And we've got this thing, min plays base is max tries minus tries over max tries. And we're going to call find new on min plays, flat mapping. If we get none, we'll try again, maybe. If we get some, and the thing that we get, so if we get some piece, some puzzle, and the puzzle has a theme, I guess Anastasia mate, or maybe also Arabian mate. I don't know what has theme, what the two arguments mean. And the odds of 3 is, and whatever odds of 3 is, we're negating that as a condition. Then we're going to try again. Otherwise, we'll say that we have success. So this seems to be maybe eliminating certain puzzles. We've got make daily, which takes a puzzle, and it's going to return a future option of the daily puzzle with HTML, and it's going to send something on a bus. This might be like an internal bus built on something like Akka streams. It might be some play bus. It might be the Redis pub sub thing. But we're going to ask, I don't know what the syntax is, bracket HTML, the renderer, I guess, to daily puzzle render the puzzle, passing in also the puzzle fen after initial move dot board and the puzzle dot line dot head. And then we're going to dot map given the HTML. So I guess this is rendering HTML. We'll call it daily puzzle with HTML, passing in the puzzle and the HTML dot sum. I guess dot sum is maybe indicating that it's not none, that the optional is fulfilled. And then recover is maybe some error recovery. Okay, so that's some stuff. That seems to be essentially looking up puzzles and asking to have them rendered. Here's puzzle.scala. Is that what we just looked at? I think we looked at daily puzzle, right? And let's just see what sorts of things. So a puzzle has a puzzle ID, a game ID. Game ID is maybe where I think the puzzles came from games. Let's take a look at it. So here's the puzzle. This is presumably the ID. This will tell you how many times it was played. I didn't really see where this came from. And it's from a game 3+0 Blitz, played by these two people. But I don't know if the game, I feel like the game does have an ID, but it's not necessarily displaying to the user. I think this is not enough information to count as a unique identifier. This is just the type of game that it is. Okay, but it does have a game ID, and it has fen. I don't know what fen is. We've seen it a few times in the code base. Let's look up fen chess. Forsyth Edwards notation is a standard notation for describing a particular board position of a chess game. The purpose of fen is to provide all the necessary information to restart a game from a particular position. It's based on a system developed by Scottish newspaper journalist David Forsyth. Okay, so I have seen these strings. In fact, I think that I showed them, but didn't mention it. But let's go to, on the left here, Come on. You can do it. Maybe you can't do it. There we go. If we go somehow to openings, maybe study. Let's make this bigger, even though I made it work so hard to go decide. Whoops. I think tools. Hey. Tools opening. Oh, there it was. Okay, at the bottom here. This is analysis. So here's Fen. And it has the notation. Is this shorter than PGN? I'm not sure. Maybe it's more compressible than PGN. Maybe it's also shorter. Maybe it contains more information. But it seems like maybe they're using the Fen or FEN notation and then exporting to the PGN notation. Each rank is described starting with rank 8 and ending with rank 1, and a slash between each one. Within each rank, the contents of the squares are described in order from the A file to the H file. So it seems like, okay, so this is the opening position, right? So we have rooks on the outside, knights after the rooks moving toward the center, bishops are, of course, closest to the royalty, queen, I guess black is on top, right? So queen is first, and then king, and then a row of pawns. It doesn't tell you which pawns are which. I guess /8 means 8 clear spaces, and then /pawns. I guess capital letters must be white, and then with king Q, or maybe that's not with. Maybe it's white. KQ. KQ. I don't know what the KQ are. Active color W means that white is about to move. B means black is about to move, and maybe that's castling. Okay, so I think that's castling information. All right, so this is the Fen notation, and they are using it. And I bet that you can just pass in. I don't know if this is. What if I just take a known valid Fen, and I'll see what happens if I just write it in here. Yeah, that seems to work. Okay, so I think that maybe Fen is the heart of what they're using. And here's PGN, although I searched for the acronym, but it's not in the Wikipedia article as an acronym. It's in it as spelled out. In the portable game notation for chess moves, Fen is used to define initial positions other than the standard word. Fen does not provide sufficient information to decide whether a draw by threefold repetition may be legally claimed or a draw offer may be accepted. For that, a different format such as extended position description is needed. So maybe PGN uses Fen. So it's used for the initial position, and maybe that's all that this is doing. So we have Fen at the top here, and then the PGN here. And so if I move around, I think it's updating both, right? Yeah, it looks like it. Okay. So why? Let's see if Lichess has I'm sure they have documentation about it. Paste Fen or PGN. What about just Fen versus PGN trade-offs? I am trying to build a chess AI with a neural network. To learn about how neural networks work and refresh my programming. And so they're asking whether to feed it FEN or PGN. Since PGN is longer, I guess that answers my question. And possibly harder to process, you should wonder whether it transports more information than Fen. In this case, the question is, does it matter in which way you reach the current board positions? Does it influence the next move? There are only two situations that come to mind, castling or threefold repetitions. Okay. So it looks like FEN is shorter and easier to process. And so I think that that's what they are ultimately using more of. At any rate, a puzzle has a Fen and a line, which is a non-empty list of UCI.moves. I don't know what UCI is, but maybe this is just a list of moves. Whatever a Glico is, plays is presumably how many times this has been played. If we go back to puzzles, it should tell me played so 25,866 times. I think that's probably what that is. Vote is a float. Why is it a float? It seems like you could do it as an int. But maybe there's some reason to use floats. Okay, and then the themes is just some puzzle theme. This is ply after initial move when we start solving. So initial ply is equal to fen read ply of fen or ply.initial. I don't know what ply is. Maybe we can find that out. Lichess ply. Rates by ply per opening. 30 ply. So is this a general puzzle thing? Chess ply. Ply is a game theory thing. In 2 or more player sequential games, a ply is one turn taken by one of the players. So it's like a half turn. The word is used to clarify what is meant when one might say turn. The word turn can be a problem, since it means different things in different traditions. For example, in standard chess terminology, one move consists of a turn by each player. Therefore, a ply in chess is a half move. There you go. All right, so ply is a half move. And then we have this situation after initial move. It's a lazy, I guess, value, which is of type optional chess situation. Or rather, it's type option chess situation, which is a kind of optional. And I don't know what this for thing is doing. Yield is presumably this is like cooperative multi-threading or something like that. We're going to set sit1 to whatever happens. So reading the fen, and we'll set sit2 to sit1.move the line head to option map situation after. Where does situation after come from? I don't know. What is the underscore? I don't know. And then we've got some initial game thing, which is presumably going to read the fen stuff. We've got fen after initial move .sum with turns initial play +1. So I guess that is somehow encoding the fact that when you have a puzzle, the first move is, I guess, really the move you make right after being displayed the puzzle. And I guess they're maybe considering that the initial game as opposed to the starting position of the puzzle. And then we have this class, which is kind of like a struct. It's just a user result. It's got a puzzle ID, user ID. Win is equal to the type puzzle win. That might be a Boolean. That might be something else. And some rating. You get 2 ratings, maybe before and after, or maybe ratings in 2 different systems. And we see more Glico stuff. I don't know what Glico is. Should we look up Glico? Maybe ratings. The Glico rating system and Glico 2. Hey. Are methods of assessing a player's strength in zero-sum 2-player games. It was invented by Mark Glickman. Okay, so this is a more general than like a chess rating thing. I don't know if it's the standard chess rating. But we have some algorithm. You determine some ratings deviation, which is the min of, I guess, 350 is some max. And then we've got this taking what's essentially a norm. I don't know what T is. I don't really know what RD0 is. This is maybe recursive. So it's found using the old ratings deviation. T is the amount of time or rating period since the player's last competition. Okay. And 350 is assumed to be the RD of an unrated player. Cool. All right. So that's cool. We've got this perf stat thing. All right. And so now we're back in puzzle. I think we've seen enough of puzzle to get a flavor for it. Let's take a look at some of these other source things. So here's game/source. This might be important. We haven't yet seen the Scala chess, which maybe we'll look at like right after this. And we haven't seen the library they use for displaying the chessboard. Although we have seen the chess pieces. Blurs. I don't know what blurs are. This is CAPTCHA. Some CAPTCHA API cross table. That's something about crossing the table, presumably. A divider and event game.scala. Game diff. So game.scala has what? So there's this function that determines, I guess, whether it's analyzable. We have player ID I guess point of view, like maybe whether you're looking as black or white. We have the start clock thing, which returns an option of progress, and it's equal to g.clock.map, taking in which is a function. I suppose it takes in a c and returns g.start with clock c.start. Yeah. So I don't know what C you're passing in, but this just starts the clock. Maybe maybe you pass in like you're going to start with 5 minutes or something, and C is like 5 or something. We have this thing about whether the player can offer a draw, and if you're started, and I guess G is the game, right? So if the game is started and it's playable, and you've had at least 2 turns. So I guess you can't draw before 2 turns. Or rather, you've had 2 half turns, so you've had at least 1 turn. And the G player of color, so you're asking whether like white can draw, whether white can offer a draw. And you're looking at the, it's not the case that the player of color is offering a draw. Maybe it's checking whether you've already offered a draw already, and you can't do it, I guess, with the AI. And the player hasn't offered a draw recently, and the Swiss doesn't prevent draw, and the rule doesn't prevent draw. Then I guess you can offer it. Go Berserk. I think Berserk is a chess variant. I don't know what Go Berserk does, but it takes a clock. And if true that the game is berserkable, and the player of this color is not already berserk, then we are going to map a C, maybe the color. No, this seems to be clock related. We're going to, the new clock is going to be C.go berserk of the color, and then whatever berserking is. Okay, here's apply move. So you give it a test game, a move or drop. I don't know what drop is. Maybe you've dropped out of the game. I don't think it's like resigning your king, but maybe it is. And blur. I don't know what blur is about. And then I think this probably means it returns progress. We'll look at what progress looks like. Or maybe it's defining a function called progress. This seems like we're calling progress on something. But I don't know. But at any rate, apply move. We're going to give it this stuff. And we've got this copy player function, presumably because in Scala, things are generally immutable. So maybe this is just for copying stuff over. And we've got this blur thing. I don't know what that's about. We get a new get a new clock history. This must be computed eagerly because it depends on the current time. And then updated is we're going to copy the game with the players. The chess is equal to the game. Some computing, I guess, whatever binary move times is, like recomputing it. We're going to load the clock history by passing in the new clock history. The status is equal to game situation status or g.status. And moved at is going to be the current time now, it looks like. And then state is going to be event.state. Turns is equal to game.ply. So I guess turns means like a half turn. Status is equal to this thing. And so on. It's hard not knowing Scala to follow the code, but it's also there doesn't seem to be a lot of logic yet. And that's probably a factor of the part of the code that I'm in. Let's see if progress is a class or something else. Class, so case class progress. I don't know what case class means, but progress has an origin game, a game, and some events. And we've got a map, which is going to copy the game. We're going to call copy, and the new game is going to be the function f has now acted on game. I guess that's like maybe a map in kind of like the Haskell sense. I don't think game is necessarily a list or something. So it may not be map in the like Python or vector sense. We have flat map, and this looks pretty Haskell-y. The two right arrows takes a next, I think, and it returns a progress. And progress is equal to flat map of double arrow next. So I guess this is maybe used for like playing through games. Maybe I think this is used in ordinary games, but maybe this is also kind of the logic that it maybe sort of creates an iterator around historical games as you're like analyzing them. Just for fun, let's ask ChatGPT, what's up with this code? It defines a progress case class, which appears to be part of the Lila codebase and open source project behind Lichess, blah, 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 blah. Yeah, okay. Represents the transition from an original game state, origin, to a new game state. So it's really a transition thing. Origin game is the initial state, game is the updated state, and events is a list of events which have occurred during the progression from origin to game. Okay, so maybe we're batching up events, and progress is kind of like just consuming them. So map applies the function f to the current game state and returns a new progress. It allows for functional transformations of the game state while keeping the rest of the progress instance intact. Flat map applies the function f that transforms the game into another progress instance and then merges the result. It applies f to game, resulting in a new progress state, extracts the new game state G2 and events E2 from the result, returns a new progress instance with game updated to G2. I don't know why you necessarily want that. So, okay, so double arrows. So double arrows sequentially composes two progress instances. So that's, I guess, just like composition. You do progress 1, double arrow progress 2. And so that's the sort of stuff we have going on. Okay, so this is like functional manipulation of progress, and as opposed to being, I guess, transitions from one state to another, we're like batching up events and applying the events as a list, is the sense that I have. And let's look at what a case class is. Case classes are like regular classes, with a few key differences, which we will go over. Case classes are good for modeling immutable data. In the next set of the tour, we will see how they're useful in pattern matching. I think it's basically like an immutable struct that can be used in pattern matching. When to use case class or regular class? If you're going to write purely functional code with immutable objects, you should better try to avoid using regular classes. Okay, so I think they might be like Kotlin's seal class. Sealed classes and interfaces provide control inheritance. No other subclasses may appear outside them. Maybe this is a different thing. All right, never mind. Forget I said that. Okay, so cool. What? Go to the... Weren't you on workspace too? You old so-and-so. All right, cool. So that's game, or rather that's progress. And I want to look at now Scala chess. Here you go. So Scala chess is the repo that has the rules for chess. We've got play.json source.main/Scala. I don't know if that's important. We've got bench. It seems to be benchmarks. So here's core main Scala. We have a file. Maybe that's file as in like rank and file. We have a hash. We have history. Mode, move. Yeah, so this looks like the, we have rank, which suggests that file really is like rank and file. Situation, I think we've seen situation show up. A square is presumably a chess square. What is there to model? I don't know. Maybe the square knows its coordinates or something. We have timestamps, unmoved rooks. Why track unmoved rooks separately? I don't know why they get their own file, but I guess they do. Speed, replay, roll, side, move or drop. We saw move. We'll look at insufficient mating material. Drop, ELO. We'll look at a few of these castles. Board. And then we have variant, opening format, and bitboard. So maybe bitboard is for like bitmaps of the board. That was the first thing that kind of occurred to me. Since the board is 8x8. Okay, so this is format. And we've got things like fen. We've got binary fen, which we should look at. Fen writer, fen reader. I guess we'll look at this stuff. This is, yeah, I guess presumably they have whatever they're calling binary fen. That's presumably like an optimized fen. I don't know what UCI is, but we've seen it before. And let's look at opening. Opening DB. This is presumably for talking to the DB. Why is there part A through E? I don't know. Let's look up part A. Let's look up part E. We'll assume that the rest is kind of in between what we see in those two files. All right, here's file.scala. This should be the file. I guess we might as well start here. There's not much here. So A, B, C, D, E, F are the different files, just like on a standard chessboard somewhere. A, B, C, D, E, F, G, H. So files are columns. And there's a square of. So if you can give it a square and it will compute the file by taking the value of the square and ANDing with OX7, which is going to do what? It's going to do something with the bit representation. So that's Gemini. So OX should be hex, right? I don't honestly remember. Bitwise AND between the value of the square dot value field and the hexadecimal constant OX7 is the effect of masking the value of square dot value, retaining only the lowest 3 bits. So I guess the lowest 3 bits yeah. Okay. And so the lowest 3 bits must contain the file. And then maybe the next 3 bits contain the rank. So it represents 0, 1, 1, 1, 1. Of course, because the next right, because 1 followed by this is a power of 2, namely 8. So this must be 1 minus it, which is 1 plus 2 plus 4, 7. Yeah. Okay. And then it just is getting rid of this, the 4th bit, and I guess also anything that comes on the other side of it. Right. All right. Okay. So that somehow the square value seems to be like a bitwise encoding of the board that we can use ANDing to get the rank and file from. And we have from car, so we can give it a car, and we're going to call file of ch to int subtracting 97. So I guess ch is some ASCII car, and then 97 I think is the ASCII lowercase a. So this is mapping from the character space into the what the numerical number is of a, or its position in the alphabet. So let's find a nice readable ASCII table with large lettering for our viewers at home. So somewhere should be A, capital A, yeah? Lowercase a, yeah, okay. So 97. So that's just getting the int that corresponds to that character. So A should map to what, 1? No, A should map to 0. What am I thinking? 97 minus 97 is 0. I'm convinced. Okay, and then we have also the ability to compare, and we're just... so if we have greater than, this is taking a single argument, so I guess we're calling it on... oh, I thought this was 0, but this is O. So what is O? And what is A? I guess this notation means that if A is a file, and we say A bigger than O, then it's a Boolean whose implementation is literally A bigger than O. And we can do that because I think under the hood, a file is just an int right there. Okay, cool. So so this is interesting for mainly the reason that when I first started thinking about, before looking at the code, how they were going to represent games, my initial thought was some sort of like bit map. And then as I explored it more, it occurred to me that that doesn't give you a lot of the features that something like chess notation has. You'd have to find a way of like storing and merging bitmaps. But I think that what they're doing is they're maybe like reading the rank and file information off of a string, which is sort of like the encoding that goes to disk of the chess game. And then for speed, as they're operating live, it seems like maybe they're using bit representation and bitwise operations. If you can dig it. We'll look at rank. I think rank is next. No, move is next. Let's find rank. I assume that the main thing is that we are going to AND with a different value here. So the that's the character representation. If you want to get the rank from a character, you turn the character into an int, and you subtract 49. That's because, why? That's because the ranks are numbers. Why 49? Is that the literal number in the ASCII table? That can't be right. Yeah, maybe it is. Here, 49. Okay, so that's taking the character 1 and or the character 0, for example. Although I think that we probably begin at 1 because that's the chessboard convention. So if you are on 1, we're going to subtract off 49 and we'll get to 0. And that's the first rank. I guess we're doing 0 indexing as is standard in computers. Okay, so rank looks a lot like file. And that's that. Situation, I don't know what situation is. A situation is a thing that has a board and some colors, or rather a color. And we have legal moves. So I guess this is like, I guess situations is a fine name. So this is like, what's the current situation in the game? You have some set of legal moves, valid moves. I don't know where they get this. I guess this is actually not hard to compute. You just look at where your pieces are, and you could just do something as simple as like try all of the moves for all of the characters, or you might have some sort of constraints that that you're keeping track of over time. Like as you move your as your pawn gets blocked, maybe it's recording that so that it doesn't have to compute that your pawn can't move every turn or every time you call situation. So we'll look at this valid moves and see if we can find its implementation. And then moves is a map from squares from from squares to a list of moves. And that's just gonna be legal moves dot group by underscore dot orig. I don't know what this notation is. Let's ask the AIs. In Scala, it is a shorthand for a function literal that accesses the orig field of the object. Okay, so this is just calling .orig maybe on the thing you pass into the function. This is often used with higher order functions like group by to specify the key extraction function. So group by, I guess, takes a field and you're going to group it by this field. This is just some notation for accessing that field. You can imagine it being group by of a function, and that function would be like x goes to x.orig. Yeah, here we go. Group by move goes to move. All right, so this is just some like syntactic sugar over like an anonymous function. Player can capture is we're going to take legal moves and ask if there exists a move that has, or like a piece maybe that has dot captures populated. Destinations is a map from square to bitboard, and it's just we're computing it with this function. Okay, so this is all good. I still don't know what drops is. Crazy house. Crazy house. Captured pieces can be dropped back on the board instead of moving a piece. Okay, that's kind of fun. That I feel like I should play with that with my kids. They would like not having the pain of losing a piece permanently. Draw in. Let's ask ChatGPT. Draw an image of a chess-based DJ creating, playing a genre of music called Crazy House, inspired by the Crazy House chess variant. See what you got, ChatGPT. Can't you draw? What about this one? I guess the O1 preview can't do it. And let's also just take this description and pass it to Gemini. That's not bad. It looks like a dope party. Oh, these are all pretty good. All right, let me know, folks, which of these is your favorite image. We'll call this one. The ability to write words has gotten much better. I see some like Atari style joysticks. Oh no, that's a person standing in front of a turntable. It looks like. And then here, we'll call this 2. This has kind of like a sci-fi, maybe Game of Thrones vibe. And this we'll call 3. And you folks, let me know which is your favorite. Okay, so and then situation.scala also has checkmate, which is, we're going to ask the variant if they have checkmate. And variant, this is maybe an interface to the Stockfish engine. We'll take a look at it. And you can offer a draw, etc., playable with history, etc., etc. So where did variant come from? Chess.variant, anti-chess, crazy house, or standard. Let's look up valid moves. Okay, so we have main variant standard. And we've got this like inline import statement. Gen non-king, gen safe king, gen castling, color, board, our king. And then we have en passant moves, or is it en passe? I forget how to pronounce this. Chess tense. Not that it matters. In passing. En passant. That's how everyone pronounces it. I didn't realize that was actually correct. We'll ask, I guess, Gemini. In what tense is the French from chess, en passant, from chess in? It's the present participle. Okay. Fatigant. Okay, great. Okay, so we have en passant moves, and this is equal to situation get, or gen en passant situation.us and board.pawns. So board.pawns, we're anding these together. I don't know what situation.us is, but for some reason we are anding it with the I guess bitwise representation of the pawns on the board. And our king, we're going to fold nil. I think the thing you pass into fold is usually like the base case. And the I guess maybe the thing we're folding is the thing that takes a king and has some checkers. We're going to look at the board attackers of the king from the opposite color. That's going to give us checkers. And the candidates is going to be if the checkers is empty, so we're not in check, the targets is going to be the tilde situation.us, I guess. So this is, I think this is like a bitwise negation, which is maybe just flipping the board to the opponent's view or something like that. I don't know what these triple dots here are. The triple colons. Gen on kings, targets, gen safe king, etc. Gen evasions. And I don't know what gen is. Maybe the gen means generate. Slider blockers on empty, else candidates. So that's valid moves. But it seems like we're doing en passant and some king stuff. But maybe I don't know. I'll ask the AIs about this. But it does look like we're computing each time the valid moves. We've got this gen evasions, which takes a king, which is on some square. I guess this is just like the square the king is on. The situation, some checkers. I'm assuming checkers is like the people who check the king and not like the game checkers, which has a similar board. And gen evasions is going to return a list of moves. And we're importing this stuff from situation. And then the sliders is going to be checkers and board sliders. So sliders, I guess, are pieces that slide, like the king, queen, sorry, not king, queen, rook, bishop. Attacked is the sliders, and we're going to fold this thing. And we're doing this like or bitwise or of some stuff. So this is, I guess, somehow checking if one of the sliders is attacking the king. Safe king is going to be gen safe king, king, the negation of us, negation of attacked, and blockers, etc. Okay, so I have no idea what any of this is doing. I don't know Scala. I don't know the underlying representations. And let's just grab all of these. But before we go, no. I want valid moves too. And then the standard object is an extension of variant. So it's a type of chess variant. And it has an ID, which is 1. That makes sense. It's the standard. Its key is the string standard. UCI key, I still don't know what UCI is, but it's I guess a type of chess. The name is standard, the shorthand is STD, and the title is Standard Rules of Chess, and it uses the standard initial position. Horde. Okay, so let's ask the AIs about this. We'll start anew. I'll say, tell me about this Scala chess code. So the valid move function is responsible for generating a list of all valid moves from a given situation. Did we see what its situation was? I think we did look at a situation. So a situation has the board, the color. It exports some stuff. I'm not sure what that means. I guess that's maybe the publicly visible stuff. It has the legal moves, etc. This seems a little bit weird. So legal moves is going to call out to variant, but the variant also is like calling stuff in the situation, isn't it? So it seems like these are mutually coupled. So valid moves takes a situation. I guess that's fine. we're just calling out to some implementation and passing in this, right? Okay. So here's a detailed breakdown. So the input is a situation object representing the current state of the game. Output is a list of move objects representing all valid moves from player to move. So gen non-king functions to generate moves for non-king pieces. Okay, that's what that means. So save king is save king moves that don't move into check. Gen castling to generate castling moves. Color is the color. Board is the board. Our king is the square where our king is located, if any. So given that information, let's take another look at gen non-king moves, because that has to be there are more non-king pieces than king pieces. I still don't know what this triple colon notation is. Let's ask that. Triple colon Scala. It concatenates two lists. Not found. Okay, so I guess these are concatenating lists. So we're concatenating list of non-king moves and the save king moves and the castling moves and the en passant moves. So where's gen non-king? Gen non-king is in situation. And it's equal to gen pawn, us, and board up pawn's mask, plus gen non-king and non-pawn. Okay. I feel like we're on a wild goose chase here. And then gen non-king and non-pawn is we're going to call gen knight plus gen, this is presumably also concatenation, plus gen bishop, plus gen rook, plus gen queen. So really, we are, it's kind of hard to see the code because the code is spread out in a few places, but morally speaking, what we're doing is we're just doing a for loop over the different pieces and computing each of their moves. And then, so gen evasions, ensuring that it's properly implemented is vital. Okay, so let's go to, let's focus on a single implementation. How about, so gen evasions, checkers, and board sliders. Checks by these sliding pieces can maybe be blocked. Okay, so evasions, like these are I guess checks that maybe you can get out of by moving, such as by moving a piece in front of your king or by just moving it to a new square. Attacked is we're going to sliders.fold I guess, did I not show it gen evasions? Here is gen evasions. Explain it to me. I'm guessing bitboard ray is maybe the like array in the sense of diagonal or vertical or horizontal squares. You're passing in the king, which I think the key is the king's space. What S is, I'm not sure. Oh, it's the slider. So you're checking if let's say that it's a bishop or something. So maybe this is like you're looking on the one of the diagonals that the king is on, and you're also looking at the s.bl. I don't know what s.bl is, and you're ORing these together. So I think that this is what we're looking at. So the purpose is to identify squares along the attack lines, raise. So I guess that is what raise are, from the sliders to the king, excluding the slider's own square. And maybe that's s.bl. Explanation. We start with an empty board, bitboard empty. Okay, so we're just imagining there are no other pieces on the board. Is that right? So that we're ignoring blocking things? Then we're folding over the sliders. We have some accumulator that accumulates the attacked squares. Slider S is the current sliding checker being processed. Bitboard.ray king S calculates the line of squares between the king and the slider. Okay, so maybe it's not the whole diagonal or rank or file. It's just the portion between the king and the slider. ORing it with s.bl excludes the slider's own square from the array. And A, or all of the things, adds the new attacked squares to the accumulator. Okay, so that's what's up. Hello, sup? What? Hey, Jareth Kumar. That's a lot of repeated letters. All right, so that tells us some stuff. Among the other things it tells me is that if you wanted to make a contribution to this, I think it's a little bit hard. It's a little bit hard to reason out. You're gonna have to spend some time like working out the bitwise logic. If you are strong in bitwise logic, then it may be simpler. Usually it's people like who have written some low level C. But even then, you have to be both strong in that and in the and in chess, so that you make sure that you're not like missing any subtleties. And then you also have to be just mindful of the Scala stuff and where things are kind of spread out. So this seems like it's very efficient. It's a little bit. It seems like it could be more clear, I guess, from a developer perspective. It's a little bit opaque how some of the logic works, how you would test it and fix bugs and stuff. But maybe there are really good tests. I'm not sure. I just saw your stream, and there was just one guy streaming. I don't know what you mean. You mean like viewers? I mean, there's just me streaming. No one else is streaming on this stream. There are other streams that have other streamers. Okay, so here's the square representation. I think at this point we have a sense. Okay. Hello. Well, welcome. We're looking at what we were doing is we're looking at the source code to Lichess. So that's what we're doing. So here's square.scala. And this is just, this should be pretty clear by now. We have a bunch of squares. There should be 64 of them. The square like C7 is going to be encoded by 50. We're going to start at 0 and count up to 63. That gives us 64 squares. And we can get the rank and file, I guess, by masking out the appropriate bits. I am in 9th grade. You are? How's it going? That's like high school? Freshman in high school? If I remember correctly. Do you play chess? Okay. So I'm going to ignore the rest of this this square. You suck at chess? That's... oh, high school sucks and you don't play chess. Well, I don't know if playing chess would make high school any better, but I think... I'm sorry it sucks. I think that's not uncommon. It'll get better. What do you do if you... I'll ask in the chat. Okay. So here's unmoved rooks. I'm not sure why unmoved rooks need their own thing, but we have this notation, I guess, of where they go. This must be rook over here, rook over here. I don't know. I guess 81 is a rook somehow. And usually not. Playing chess usually does not make you popular. But I think it's a really good game for, it's a good strategy game. If you want to learn strategy, it's good for exercising your working memory. There's a lot of stuff like chess, music, things that you can do that exercise your brain and develop a skill that you get better at over time, and that are very rewarding. So I don't think it'll make you popular, but you might enjoy it. So just, nope. Sorry, this is not the place for pickup lines. But you can listen to the song One Night in Bangkok from the musical Chess. And I think that has some sexy chess themes, if that's what you're into. Okay, so you can get the unmoved rooks from board. And maybe this is just checking whether rooks have been moved or not, as opposed to having like specific behavior associated with unmoved rooks. You have this apply thing. You can give it a bit board and it'll return unmoved rooks. Guess unmoved rooks from boards. We assume rooks are on their initial position. Try to guess the side of the rook at position square. So yeah, I don't know what this is about, but it seems to be mainly like checking whether the rooks have been moved. Why do you want to know that? Well, one is probably, of course, castling. If you move a rook, you can't castle anymore. Is there anything else? I'm not sure. I'm not really aware. Maybe there's, in some chess variants, you need that. But you also... Oh, okay, so hang on. So for unmoved rooks, you not only need to know whether the rooks are in their original space, but you also need to know, like, did you move one space and then move them back? So you need something about their history. And I don't know how they do that. It seems like you could just record some Boolean once the rook has moved. Where am I from? I'm from the New York City region in the US. Was I popular? No, I was not. I was kind of like neither popular nor non-popular, I guess. I mean, I had friends, people liked me. I feel like I wasn't. I don't feel like I was in like any of the high school like movie stereotypes. But I did err on the side of being a nerd, and at the time I was really into music. I was in a town where music was a big thing, so that probably worked to my advantage. But in general, school kind of sucks. Let me rephrase that. For a lot of people, school is very difficult. It's the first time you have to socialize with a bunch of people. As you're getting to high school age, socialization becomes more important and harder. Like when you're a little kid, you can just walk up to someone and say, like, do you want to play? And you can play games. In high school, there's more of like a game theory, Machiavellian element to it. Like friends can like get upset or drop you really quickly. Popularity becomes more important. So for a lot of people, it's a real challenge, especially a lot of people who end up going into things like coding. You're not going to find among top tier engineers, you're rarely going to find somebody who's like super popular in high school. So I think the general idea is like you should know who you are and what your values are, and just try to be like the best person that you can be, and that's going to serve you well in the long run. And you might just have to not enjoy school for a few years, but try to make the best of it. Because if you if you try to have fun and enjoy it, I think you're going to have more fun than if you try to like than if you're like always worried about like what your standing is. Yeah, you do what you do. That's right. Okay. So here's move or drop. I think move or drop is from the Crazy House game. I don't know what else. Yeah, I guess. So drop means you can drop like a piece on the board instead of a move. And so move or drop seems like this is really just accommodating variants where you can drop a piece. And so instead of like moving, you call move or drop. And I don't know if there are any variants that have dropping other than Crazy House, but that's that. I do want to know what UCI is. This is like the 5th time we've seen it. UCI.Scala. Cats.syntax.all. UCI string. This seems to be maybe some notation. Universal chess in something or other. Universal chess interface is an open communication protocol that enables chess engines to communicate with user interfaces. Okay, so it's some chess protocol. Examples: E2, E4, E7, E5, E1, G1 is white short castling. Okay, so it seems like maybe you're just streaming chess moves. All right, so that's UCI. I don't know if they are using it internally or if it's more to communicate with and support integration with other engines or other tooling. Tell me how to complete 9 math chapters in one night. Are you behind? Have you kept up with your homework? Because if you're behind, you have to do different things than if you've kept up, I guess. All right, so here's move. So move is a case class, which is, I think we've decided as non-Scala people that this is essentially some like an immutable class that's really like a C struct, but or maybe like a Haskell record, something to be used as immutable data and passed into like pure functions. I think. I don't know. If that's way off the mark, let me know. If it's slightly off the mark, also let me know. So move has a piece in orig, which I guess is the origin, the destination, which is or dest, which is the destination, the situation before the move, after, which is a board. So we have a situation from before. After we have a board, but I think we don't have a situation. Capture is an optional square. So if you don't capture anything, it probably won't be filled out. But if you do, it'll go here. If there's a promotion, it'll go here. Promotion is like when you get to the end with a pawn and you promote it almost always to a queen, or you can also promote it to like a bishop or a knight. I'm sure you can also choose not to promote. I don't know if promotion is mandatory. You can promote maybe to a pawn, I guess, in that sense. And en passant, which is Boolean, which is just recording whether you're doing this crazy move. Now, I want to know what the history of this move is. I think it's old. I think it's way old, but not as old as chess. History, here we go. In early versions of chess, the pawn could not advance 2 squares on its first move. Oh, okay. So yeah, that's the innovation. So I guess to speed up the game, they added the 2 square advance, and then to ensure that 2 square advance didn't remove power from the pawn, they added this ability to like capture in passing to speed up games. There we go. Between the 13th and 16th century, the en passant capture may have been introduced at that time, or it may have come later. References to en passant capture appears in the books by the 16th century Spanish chess master Ruy Lopez de Segura. I guess I'll read about en passant in Wallabag. And let's read about Ruy Lopez. No, I don't want the opening. I want the man. I guess this is a picture of him. Is he this guy? Or is he one of these guys? Ruy Lopez playing Leonardo di Bona in the Spanish royal court, also depicted is King Philip II of Spain. Okay, that makes sense. That fancy guy is the king, I assume. And they are having some exhibition, and the king is just like sitting here and has his feet on it. He has a nice foot pillow. There's a cool painting in the background. He's got a nice marble. I thought this was a doorway, but it's got some sort of crest. And he's got a cape. People don't usually wear capes anymore in playing chess. And these dogs are somehow chained. Chained to what? I'm not sure. I don't know about that. So if you want to do a lot of math you don't want to do too much math in one night, but like you can always read ahead, become familiar with the math, and read it in passes and get familiar with it over time and do problems. But also like at some point you have to do problems and like compare them to the back of the book or whatever happens in high school. But you also want to play around with some of the problems and try to like guess what might happen if you do this or do that, and just have a sense of play. And if you do that, I think you'll have a better time with math. All right. So, and then we also have finalize after. I don't know what this means. Rethink about how handle castling. It's quite messy and error prone now. So this is a to-do item. I don't know if this is showing up in an issue, but this might be a place to start. So let's take this whole thing and pass it to ChatGPT. I'll say, consider this code and the to-do item about castling. Do you think the to-do statement is correct? And if so, describe how you think the logic is messy. And while it's thinking about that, let's look up to see if this to-do item shows up in the issues. We'll just look up castling. Regression with regard to castling rights of inner rooks. This is, I don't know whether this means opened or closed. It's closed. Okay, so purple's closed. Let's go to this search interface here. So there's only two open. Everything else is closed. Or two open. There are only two issues open at all, and there are none for castling. But we have some of these other ones which were closed. It looks like many years ago, except for the regression. Here's drop.scala. I think this is probably just support for dropping a piece in the chess variant. ELO, I think this is a rating, and I'm just going to move along. So I think we've seen enough of the, what is this, magic, chess magic. This is some sort of encoding of position information. I think we've seen enough of the Scala chess. We have fen reader and writer, and we have binary fen. So the binary fen, pawns, etc. We're going to start with bit board empty. Turn is equal to white, and we're going to have this unpack piece thing here. And we're doing a lot of ORing, or equals to. Crazy data. This is presumably for a chess variant. Presumably crazy chess. Okay. So I'm not going to look at that because we've been here for a while, but it seems like fen is a big part of how they do things. Here's an opening DB part A. Okay, so this is a Scala file that could be a JSON file, but they're, I guess maybe for speed, that you don't have to parse it. They're defining each of these openings as a Scala object. And for example, this is just some number game. I don't know if this number corresponds to anything outside of Lichess. but this is, I guess, emblematic of the Polish opening. Polish opening, Indian variation, Schiffler attack. And I guess it's not a full game, but instead the like fan, it looks like corresponding to the opening, which it looks like it's just 2 moves, but I'm not sure. And so this is just a database of openings. That's part A, and then part D is just more openings. And so when we looked at openings, I was imagining they were pulling them from a database, but maybe there's just not enough openings to justify a database. They just put them in the source code. Looks like. So that's cool. So what haven't we seen? We haven't seen really any of the web stuff. I don't know if we want to. We have static context theft prevention. PagerDuty. This should be like PagerDuty is a company that like provides DevOps SRE type people with like pager integration to monitor their deployment. So if something, if Lichess stops responding during like an important tournament at a time when the main developer, let's say, is asleep, it'll wake him up by paging him, presumably on his phone and not on a literal pager. So in UI, we have the authentication UI, the board editor, some CAPTCHA, site message, learn UI. Let's look at learn UI, contact bits.scala, open graph. I don't know what open graph is. Open graph. We have fragments. It's a private Twitter object, tag, card summary. Something about Twitter. The Open Graph protocol enables any web page to become a rich object in a social graph. Okay. So I think this is maybe like support for the social networks. Here's bits.scala. We have a stage. This is an empty Lichess preview website. Go to lichess.org instead. Why is this bits? I'm not sure. This is maybe the development site or something. We have some stuff about like Mastodon, GitHub, YouTube. This seems also to be social integration. Learn UI is, I hope, the UI where you like learn. TRL is, I don't think, total request live. I'm not sure what a page is, maybe a web page. TRL learn chess.txt dash TRL by playing. Translation probably. And it's going to return a page module, learn, with a JSON object that has data. The data was passed in where? I'm not sure. And we've got internationalization, preferences, about some stuff about coordinates and destinations. The CSS is, I guess, the learn style. Learn chess by playing. You don't know much about chess? Excellent. Let's have fun and learn to play chess. That's the description in the graph. Although that's English and not the translated version. But I guess maybe that's somehow, the translations are somehow encoded in here. Zoom is maybe going to zoom in on this particular part of the UI. And then here's the keys for the internationalizations, like the pawn, castle, etc. So let's take a look at what this learn page looks like. Okay, so learn. Chess basics. Okay. So I don't see where it says you don't know much about chess. You know how to play chess? Congratulations. All right, so it's going to play some sound. I don't think you guys can hear that because I turned it off for you. But you do this, and it says, I did a great job. I did do a great job. Thank you. So I think that this is the learning thing. I don't know where these puzzles are stored, but presumably this is part of the code that serves it up. Okay. So that's fine. And then we're back in main. we'll just do a quick look to see if there's anything. There's a DSL. There's JSON.Scala. I'm going to guess that's just for parsing JSON in general, not something specific to chess. Yeah, it seems mostly general. And then DSL is maybe a domain-specific language. Or I don't know. So some stuff about read pref, call, doc, end of top-level operators. Divide, multiply. So this is maybe element builder. Represents an initial state of an expression which has only the name of the field. This seems to be BSON related, but I'm not really sure. It's, I guess, stuff about manipulating JSON, maybe like essentially utilities, but I don't know. All right, I think that's just about it. I kind of want to see at least the main like chess canvas thing. Let's see if we can find that. Probably it would be in UI, unless it's a separate repo. About Lichess, chessboard, library, probably TypeScript. Yeah, that's right. Chessground. Okay, so this is the Chess UI, a free Libre open source chess UI developed for Lichess.org. It targets modern browsers as well as mobile development using Cordova. All right, so this is the source. I don't think we're going to really look at this much, but we've got things like animations, auto pieces, drop, draw, explosions, pre-move, etc. And so this should do things like when I click on a piece, it'll show me information. Like let's go into a puzzle, I guess. So, okay, when I click on a piece, these dots will tell me where I can go. So I assume that's part of the UI, or maybe the UI gives you like all of the dots and you like pass in something that's from the Scala chess engine that tells you which dots are valid or something like that. Okay, so that's the UI. And I'm realizing that before I go, I want to see some of their anti-cheating stuff. We'll close all of these out. Opening. Open firewall. So this is seems to be calling some other service. We've got some rate limiting. We've got some firewall stuff. And it seems to be maybe supporting an API for looking up chess openings. And practice is what? This is maybe also API related. I don't know what relation is. Relation is a thing that takes an environment and an API call, I guess. It extends Lila controller of environment. And it's got render actions, or render actions maybe. I don't know whether to emphasize render or actions, but you give it a username and a mini Boolean. Don't know what mini would be for, but we have this using context thing. And if you, it says for user relation, API fetch relation. Okay, so I think this is like maybe like relation in the database sense. Tutor, Bobby, okay. So let's look up the, on the architecture diagram, which I have in front of me in another monitor. Let me take a look at what the anti-cheating thing is called. Okay, so the Irwin anti-cheat thing. So let's look up Lichess Irwin. And presumably that's going to somehow compare the moves that you're making with the like output of something like Stockfish. Is Irwin on vacation? Irwin, AI Hunter. PV0, rate by ambiguity. 98% overall assessment. Okay, so this, I guess, is maybe generating a report for each person. I don't know if they do this in real time or if this is something that's run. I feel like it must be run maybe in batch mode. So we have some web app, but I don't think that's the real thing that's doing anti-cheat protection. We've got TensorFlow. Okay, so it's some AI model, I guess, that is going to read the games presumably from MongoDB. Build a database of analyzed players. If you do not already have a database of analyzed players, it will be necessary to analyze a few hundred players to train the neural networks. On Python 3 main.py, no assess, no report. Irwin, named after Steve Irwin, crocodile hunter, started as the name of the server that the original CheatNet ran on, now deprecated. This is the successor to CheatNet. Similar to CheatNet, it works on a similar concept of analyzing the available PVs of a game to determine the odds of cheating occurring. PVs, you don't know? The bot makes improvements over CheatNet by taking a dramatically more modular approach to the software design, et cetera, et cetera. So there's some model. Let's see if we can find the AI model. I'm going to guess it's probably in modules. Auth client DB fishnet game HTTP Irwin. Probably Irwin. Training models. So analyzed game.h5. I think this is a module checkpoint or a model checkpoint. Do you think GitHub will kick me off if I ask to view it raw? 1.9. Yeah, no. It's just going to let me download it. Okay. So analysis report and game move report player. It must be in models, but not. Training. Evaluation basic model training.py. And we've got a batch named tuple. This train function, you're going to give it a reference to itself, epochs, the number of training epochs, rather the whether it's filtered, and something about whether it's a new model. And we're going to call self basic game model fit and self basic game model.save model. And we're importing basic game model. So let's look at that. So create model. We're going to look for the what I assume is some config, maybe a checkpoint. Model already exists, opening from file. So I think that's essentially a checkpoint. We've got this move stats input, which is, I guess, move statistics. It's a input layer. We're using Keras or whatever it's called, or just ordinary TensorFlow, Keras. Okay. And we've got somehow 60 by 8 of type float, 32. You've got piece type, which is an input of type 60 by 1. I don't know what 60 is in these cases. And then we have a piece embedding, which has input dimension 7 and output dimension 8. Why 7 and why 8? I don't know. Let's see, there are 64 spaces, so I don't think that's what the 60 is from. There are not 8 different pieces, right? Well, maybe. So we've got king, queen, rook. I don't know if the 2 rooks are counted separately. We have 2 bishops, 2 knights. That's 5. Pawn. 6. Am I missing something? I don't know. Okay, but at any rate, we're going to reshape the stuff, I think that we got from the piece embedding. Then we're going to concatenate the move stats inputs and the reshaped piece embedding. And the embedding is going to consume the piece type. And then we've got some convolutional net blocks of Siamese network. I don't know what a Siamese network is, but we've got conv1 is a conv1 TD, a one-dimensional convolution with 64 filters, kernel size of 3, and ReLU activation. And then we give it to a dense linear layer, and then another convolution with looks like about the same number of filters, larger kernel size, same activation. And then we pass it to another dense layer with a sigmoid activation. Why? I have no idea. Then another 1D convolution. Again, 64 layers, larger kernel size. So we're increasing the kernel size here. And then 2 dense layers in a row, 1 of size 16 with ReLU activation and one with sigmoid. And then we're going to flatten the dense for output. Then another dense layer. And then the convnet output is another dense layer, this time with 16, whatever this dimension is, size 16, I guess probably like, I don't know if that means like 16 by 16 matrix. I think this dense is basically just a linear map, right? So I'm guessing it's a square matrix. I forget how it works. And then we're passing out the dense. It's like essentially the dimension that the linear map is mapping over. And then we have some LSTM blocks. And so on. And then we merge the LSTM and the convolution. So this looks like a serious network, lots of layers. A Siamese neural network, also sometimes called a twin neural network, is an artificial neural network that uses the same weights while working in tandem on two different input vectors to compute comparable output vectors. Often, one of the output vectors is pre-computed, thus forming a baseline against which the other output vector is compared. This is similar to comparing fingerprints, but can be described more technically as a distance function for locality-sensitive hashing. Okay. So I'm curious, like how they arrived at this particular, at these particular layers. Let's ask the AIs. I'll say this model. This model predicts chess cheating. Where do you think the model came from? Is this possibly from a published paper? If not, what process do you think went into deciding what kinds of layers and how large? Have I read the source code of the AI players on Lichess or Stockfish yet? I have not. We're definitely not going to do Stockfish on this turn, but I will, before I go, I'll take a look to see if we can find out at least where the AI player stuff is and what it looks like. It might just be a trained network model like this. It also might just be Stockfish's. I feel like when I've used Lichess in the past, you can like select a Stockfish level. So I'm wondering if that's what's up. And I think Stockfish has moved to a neural network in recent versions, but I don't think it's like a neural network that has to run on your GPU. So the model that I provided appears to be designed for detecting cheating in chess games by analyzing sequences of moves and associated statistics. While I cannot confirm if it originates from a specific published paper, it does seem to be inspired by common practices in sequence modeling and neural network architectures used for similar tasks. The code references Irwin basic file and includes comments about building blah, blah, blah. So the move stats input represents statistical features of up to 60 moves. Okay, so that's what the 60 is, each with 8 features. These could include metrics like move times, engine evaluations, and other numerical indicators related to each move. The piece type represents the type of piece involved in each move. An embedding layer is used to convert the piece types into an 8-dimensional vector space, capturing semantic relationships between different piece types. Okay, and then embedding and concatenation. The piece type embeddings are reshaped and concatenated with the move statistics to form a combined input shape of 60 by 16. The combined input now contains both the statistical features and contextual information about the pieces involved. And in the model components, we have a CNN block to capture local patterns in the sequence of moves, such as specific combinations or motifs that may indicate cheating. We have multiple conv1d layers with varying kernel sizes to capture patterns at different scales. Okay, interleaved with dense layers to add nonlinear transformations. Okay, so I guess it's that makes sense. We have the nonlinear activation functions, and I guess they're just saying that like the point of this. So the nonlinear activation functions are just what they are, but you need the dense layer to learn a specific nonlinear transformation of the previous layer's output. Activation functions alternate between ReLU and sigmoid to introduce nonlinearity and control the output range. A flattened layer followed by a dense layer reduces the dimensionality and prepares the output for merging. Then we have LSTM blocks to capture the temporal dependencies and sequential patterns in the data. And the layers are initial dense layer with a dropout layer to reduce overfitting, and a conv1d layer to pre-process the data before feeding it into LSTMs. Then we have stacked LSTM layers with varying units and activations. Some LSTM layers have return sequences true, allowing the subsequent layers to process the full sequence output. And the final LSTM layer outputs a single vector representing the sequential information, and they merge an output. Likely process is empirical experimentation, domain knowledge, layer sizes. Likely balances model complexity with computational efficiency. Okay, so that was useful. Java or C++? This is in Scala. Although the model we're looking at right now, like immediately this second, is in Python, but most of the other Lichess stuff that we've looked at is in Scala. And let's, before we go, look for the Lichess AI player. This is just an idea on the forum to mimic a specific style. That's not what we want. We have a bunch of different bots, easier AI levels. This is forum. So here's this thing again. I thought I did see something about bots. I don't know. I still don't know what YOLO is. Let's try Lichess YOLO. YOLO D. I think that's a user or a team. Maybe YOLO is a Scala thing. Scala.js, Google YOLO. Abandoned. The Open YOLO library. I don't know what this is. I don't know that this is the same YOLO. All right, let's try another tactic of looking in the Lila org. We have Lichess bot. That might be useful. We have YOLO-DB. It's a weakly replicated DB for low value documents. Okay, maybe YOLO means that they're not taking data persistence seriously, which would make sense for the name. And we have this configuration. YOLO is some MongoDB database, presumably on developer machines, because this is listening on 127, or rather the MongoDB instance is listening on 127.0.0.1. So I'm just going to assume that YOLO-DB is just their name for stuff that they don't care if they lose. And that leaves us with CRBot, SandbagBot, and Kaladin. Let's try Kaladin. Kaladin, this looks promising. This machine learning tool is aimed at automating cheat detection on Lichess using insights. Example, it is built using CNNs on Keras or TensorFlow. What? How is this? Was I looking at the wrong model when I was looking at Irwin? This is from 3 years ago. I don't remember when the Irwin thing is from. 6 years ago. So maybe Kaladin is the new thing, but it maybe has been. I don't know. The architecture diagram said that that they were using Irwin. Lichess tries to combat cheating at online chess using two machine learning based components, Irwin and Kaladin. As a researcher and machine learning expert, I have taken these mechanisms apart by looking at the source code, etc. I don't know how they relate, but somehow they are both detection algorithms, it looks like. Should we look at the... Oh, we've already seen one model. I don't know if we need to see the other one, but here's Lichess bot. I think this is maybe for handling bots. You can create and operate a bot on Lichess. What if we just go to lichess.org and we create a game? Obviously, we should play Crazy House. 165 minutes per side. I don't know what the increment in seconds is. Yeah, it'll be a casual game. And I want to play it against the computer. How do I do that? What just happened? I don't think I want to do this. Sorry. How do I message this player? All right. I think I'm going to tank my Lichess representation. Okay, so can I resign? I think I can resign after the first turn if I read the thing correctly. I'll just abort the game. Okay, I wanted to play with... Here we go, play with the computer. It was blocked by my microphone. Okay, so the whoever asked me... yes, hidden behind the... I was hidden by the chat. All right, thank you. Whew. Okay. Thank you, Tuan. I don't know how to pronounce your name. Thank you much. And it looks like the computer is Stockfish. Stockfish 14 level 1 through 8. It seems like they're running Stockfish on WebAssembly. And so let's just like aggressively lose the game. So the AI is possibly not a real AI, although I think Stockfish has been moving in that direction. So let's see if we can at least learn a little bit about it. Strong open source chess engine. I guess I'll just view on GitHub. Why not? Level. Let's look at level. Struct skill. Skill structure is used to implement strength limit. Move gen. And let's see if there's a model. Let's look for maybe TensorFlow or neural net. Let's look for neural. The NN UE extension, something about a neural net. Storing the neural network for the NN UE evaluation. Okay. So there's this alpha beta search, which I think is a non-AI. I assume this is like alpha beta pruning. Alpha beta pruning is a search algorithm that seeks to decrease the number of nodes that are evaluated by the minimax algorithm in its search tree. It is an adversarial search algorithm used commonly by machine playing for two-player combinatorial games like tic-tac-toe, chess, Connect 4, etc. Okay, we'll read about alpha beta pruning. And then there does seem to be some AI. This will be like a preview. And then I think that we'll have to come back to the Stockfish engine in the future. I'm going to guess they may have gone with TensorFlow because it's older. They may have gone with PyTorch. What else is there? Keras? Okay. This is some diagram. There was apparently a Hacker News discussion on it. Is that what I just saw? Reposting my comment from Hacker News. If anyone wants to experiment with training these nets, it's a great way to get exposed to a nice mix of chess and machine learning. There are 2 trainers currently. The original one, which runs on CPU, and a PyTorch one, which runs on GPU. Great. 4 months ago, this looks relatively current. We'll just take a quick peek, the quickest of little peeks at the implementation. This is some RNG and some data format stuff that looks like these are C headers. I assume unless there's another .h extension. Hafka, I don't know what Hafka is. This is some sigmoid thing. This looks possibly a very serious implementation by people who know what they're doing. We've got this coalesce half-weights thing. We've got 3-layer fully connected network of huge size, 3072, followed by 15 and then 32. And then layer stacks. NN is torch. So we've got linear. So what is this? 4 linears. Yeah, with bias, and I don't know what any of this is doing. This is like some parameter stuff. I don't know PyTorch. And then this is the forward pass. L1 through L whatever are the layers, I assume. It seems like this is just a bunch of linear layers. Although we have a double feature transformer slice. Feature set is an instance of feature set defining the input features. Okay. I don't know what double feature transformer slice is. Feature transformer. I don't know if this is transformer in the sense of machine learning or if this is just like we're transforming the features. Let's look up attention. Let's look up transformer. So we do get the feature transformer hits. Let's look up LSTM. And let's look up NN dot, which I'm not sure if I have to, I guess I don't have to escape the dot. Yep, it seems like mainly multiple linear networks, but large. I don't have a sense of whether I could run this on my GPU. What does Reddit say? Stockfish training AI GPU hardware requirements. There may be no documentation of it. In order to have hardware for Stockfish, which does not suck, but also does not require you to sell your first newborn, just get some 8-core/16-thread CPU with 16 to 64 gigabyte of RAM and the cheapest integrated graphic cards you can find. That's from 2023. So I guess they're just saying train it on the CPU. All top players use the cloud or the private cloud. Okay. So, okay. So this has some stuff. It sounds like people are using the cloud, which makes sense. I'm sure you can do some training on like Colab for free, but probably not much. And it seems like it might be bigger than most GPUs, although I don't really know how large a linear layer you can fit on a like, I don't know if you need 16 gigabyte of RAM, 24 gigabyte if you need like one of the like the professional AI accelerators or whatever. But regardless, that's it for Lichess for me. We have seen a lot of cool stuff. It's a great project, and they seem to really be welcoming and rewarding to people who contribute. And so if you know some code, then I recommend you look at their documentation and see if there's a way that you can help out. Thanks for watching.